There are some topics which I've been wanting to make GameMaker videos on for a while, but I tend to avoid them because they tend to be sources of drama within the GameMaker community on frequent occasions, and I don't want to make it sound like I'm, like, calling someone out or dunking on someone when I do cover them. Anyway, so for some backstory on what you're looking at right now, a couple of weeks ago, I wrote an article on the GameMaker forums. In this thread, I went through probably like 20 or so bits of GameMaker optimization advice that have like done the rounds on the internet over the years. And some of them I've made videos on in the past, such as texture compression and a bunch of other things in here, and some of them I haven't. And today I'm going to talk about something that I put way down at the bottom in the F minus tier, the anti-optimizations tier, because these are things that will actually make your game slower instead of faster. And that is the subject of avoiding GameMaker instances in favor of using like structs and methods and that sort of thing. So what actually are we looking at? So this is a little test scene comprised of, I think, 30,000 GameMaker instances that don't really do a whole lot. If you go into its step event, it's going to update its position and it's going to jump to a random new point in the room if it leaves the room. And in its draw event, it's just going to call a draw sprite extended function call with some position, scale, rotation, and color. So these are pretty basic objects, but in GameMaker, in the background, the GameMaker engine will do some things to instances whether or not you actually need it to and whether or not you actually want it to, such as updating the object's X and Y position based on H speed and V speed. There are things like updating the image index based on image speed. A lot of the built-in stuff, ticking down alarms, things such as evaluating like outside room or like animation end or update events, that kind of thing. All these things are things that GameMaker will do in the background regardless of whether or not you really need them to, and theoretically, many people over the years have proposed the idea that if you just, like, didn't do that, your game would run faster. And the form that not doing that typically takes is by creating a struct, giving each struct a, like, step and draw method, and instead of having a bunch of GameMaker instances active in your room, you just iterate over the list of those structs and call the respective methods on them, and use that to drive your game instead. And that sounds like a reasonable expectation, right? And I'm serious when I said in the introduction that I don't want to make it sound like I'm like dunking on someone when I make this video, because many people over the years have attempted this, and pretty much everyone comes to the same conclusion. I myself, back in the summer of 2020, when the GameMaker 2.3 update first came out, like, literally one of the first things I did when that update came out was doing like an entire game just based on that without any GameMaker instances to see if it would make a difference. And well, let's just let the results speak for themselves. So I'm going to run this in debug mode, and I'm going to look at how the game performs in the profiler. The profiler is a wonderful tool which we are going to be making heavy use of in this video. If you've never seen the profiler before, I have made a video in the past on how it works, which I would recommend going and watching, because it is going to be fairly core to what exactly we're going to look at here. So if I run the profiler for a while, I'm going to get to see exactly how long each individual action actually takes in the object step event and draw event, and basically we'll see how expensive it is to actually run this little demo, and we'll see a breakdown of how long individual actions takes. And right now we're getting about 30, mid-30s FPS, maybe 40 on a good day, and this is actually slightly lower than what you would see if you weren't running the game in the debugger, because when you like profile the game, it does take a little bit longer because the debugger has to like spend time investigating each function and asking how long it took. Anyway, I'm gonna call it for, we're getting about like 35 FPS, give or take, and each frame is taking about 11 milliseconds. Actually, it'll be like more like 11 plus 8 plus, so let's say about 20 milliseconds to run between the step and the draw events. And some of that is just like intrinsic to what we're actually doing. So calling the trig functions 30,000 times, it's going to take a fixed amount of time. Calling the point and rectangle function is 30,000 times, it's going to take a fixed amount of time, the draw sprite extended function. But if you want to see, or at least if you want an indication as to the cost of all the stuff that GameMaker does to instances in the background, you can go to the drop down here where it says My Code, and you can click on engine code, and this will be all the stuff that's like peripheral to what you're actually doing. And then you can click on the combined section, and this will show both. So if you expand the do a step heading here, this is like most of what happens when you in the step event of your game. So you have the handle step section and the draw room section, and then you can expand this further into the individual items that might be called within there. And I'm gonna close out of this because I don't need it anymore, and I don't want my computer fans to like completely lose their minds. I guess the number that I'll go with is that do a step takes about 23.8 milliseconds when I'm using GameMaker instances, and that counts not only the obvious stuff, such as the step in the draw event, but also, for example, handle instance movement takes a little bit less than a millisecond. That's, as I mentioned, things like the built-in H speed, V speed, gravity, friction, those sorts of things. Update active lists, I think, is like clearing instances away if you delete them. I can't remember exactly what this one pertains to. Anyway, I'm going to expand all this again, and I'm actually going to go take a screenshot of this profiler, and I'm going to just save this for later. We're going to go open up Microsoft Paint, paste that in, and we're going to use that as our point of reference to compare when we make some changes to this. So this is all GameMaker instances, right? Now, what if instead of instance creating 30,000 of these things, what if we instead had an array, and I'm just going to call it things, and instead of creating instances that do these things, we array push onto the things array a little struct which contains some data. So, for example, the data that you would initialize in the create event of these objects. So the color, rotation, and direction of these objects. We can go let's properly indent this. Use a colon to make it more JSON friendly than regular code. Commas instead of semicolons. So these are going to be the color, rotation, and direction variables. I also want the X position. Which is just going to be a random value between 0 and the room width and height. And also the sprite index, because I am referencing that. SPR, whatever. I put a lot of thought into these variable names, as you can see. So this is going to be sort of our create event. We can also have a step event, which I'm just going to make a method, which I'm going to call step like this. I can just take this code, which is in the actual step event of the actual object. I can dump that in this here method, indent that properly. That's going to serve as our step event. And the same thing for the draw event, which is just going to be this draw sprite extended function call. Like this. And if I run the game now, nothing is going to happen. You're not going to really see anything because the data has been initialized, but we're not like doing anything with it. That's a pretty boring game if you ask me. And if I go into the step event, we can go and iterate over for var I equals 0. I is less than array length of the things array I plus plus. And we can say things index I dot step, and we can do the same thing in the draw event over here. We can iterate over the array, and we can say things index I dot draw. And now if I run the game, we're going to see that things are a little bit different, and in particular, you'll notice that the frame rate that we were looking at earlier has gone down by probably like 40%, 30%, something like that. If I go into the profiler and run the game, we can see exactly how long the frame time is. So it was like 22, 23 for the total do a step the first time when we were looking at the just regular GameMaker instances. And right now, when I've converted that to using structs and methods, we're looking more at like 42, 43. So this is almost taking like twice as long as it was when we left it alone. What the 35 FPS that I was looking for was when the profiler was running, wasn't it? So now it's more like 20, like literally half of what it was. All right, I'm gonna turn that off, and I'm just gonna expand some of these. We can see if we look through the actual timings in here, we'll notice a few things. So the timings of individual operations are more or less the same as they were in the original version. So we have this like the trig functions are both taking about 0.8 milliseconds for 30,000 function calls, and that's basically the same thing that we see here. The point and rectangle. 30,000 of those function calls were taking 0.8 milliseconds. The draw sprite extended was taking like 3.5. So individual function calls haven't changed. These are all the same as they were earlier. What has changed is going down here, the update active lists. This is slightly less time than it was before. I don't think that's really that interesting because it went down from like 2 microseconds to 1 microsecond. In particular, the handle instance movement part of the step event, that went down for like another 0.8 milliseconds to 0 because we only have one instance and it doesn't take very long to update one instance's like position based on H speed and V speed. So that's cool. We managed to carve out an entire millisecond out of our 20 milliseconds of frame time. Unfortunately, we added another like 19 milliseconds out of nowhere. And if you look through the profiler and figure out like what the actual individual timings are, we can see that we could see some things like the actual iterating over the list and calling the draw and step methods. Those are each taking about 10 milliseconds on their own to go over 30,000 instances. And that's like as much time as the actual step and draw events were taking when we were doing this. And if you're optimizing your game, that's like exactly the sort of thing you want to not do. So if you look through these, if you look through the profiler, you might notice a few things where maybe we can improve things. So calling this array length function 30,000 times in both of the loops in here, that's a little bit excessive. If you'd like, you can simplify this a little bit. You can use what I usually prefer to do when I'm iterating over an array in a for loop, and that's going to be I equals 0, n equals the array length. In the update condition, I is less than n, I plus plus. And that will go and eliminate the invocation of array length in like every time you go down the for loop. And that's going to save a little bit of time. That's going to come out to like 0.6 milliseconds in the step event and 0.6 milliseconds in the draw event. You can also do what some other people might like to do. You can take this a step further and you can use a repeat loop over the array instead of a for loop. And this isn't going to make a huge difference, but some people like are very anal about this, and it's not big enough of a deal for me to like care that much, even though I don't think it's really worth it. So you can sort of reformat the for loop using a repeat loop, which does at least part of the update in GameMaker runtime code, which is going to be like infinitesimally faster than using an actual for loop. But you do now have to go out of your way to denote and update the loop index like this. And we can do this in the step event. We can also do this in the draw event. Call the draw method when it's appropriate. And what was this in total? So 41.68 milliseconds of frame time in total. If I run this, we might get slightly under 40. We might get like 39 and change. Let me go back to the profiler. Let me start profiling again. And unless I did something and like this didn't save, which I don't think is actually what happened, it well, barely made a difference. We're still taking in excess of 40 milliseconds to do this, so not even what I said by simplifying the loops. So what else we might look at is that since it looks like a lot of the actual cost of doing this is in calling the method on the struct itself, what if we went and stopped doing this? And what if we went and instead of calling a method that's like draw or step or whatever on these structs, what if we went and just directly actually ran the code that would constitute the step and draw event of each of these structs? So for the draw event, we can just take the draw sprite extended function. We can use the with statement to basically change the scope of whatever code is running to that of the struct, and then we can just call draw sprite extended from the scope of that struct. We can do the same thing, and I'm just going to take a moment to paste and reformat that. We can do the same thing with the step event, so we can replace the direct function call in both the step and the draw event. We can run the game again to see exactly how this is going to shake out, and let's head back over to the profiler over here. So we can see that that definitely did make a difference. It knocked out about, let's say, 5 milliseconds of frame time from both the step and the draw event, and we've gone down from like 40 milliseconds of frame time to about 30. And that definitely is an improvement. That's about 25% increase over what we were doing before. But in comparison to just leaving it alone, compared to regular GameMaker instances, we're still like 7 or 8 or maybe 6 or 7 milliseconds of frame time behind just not doing all this and letting GameMaker use instances to handle the step and the draw event and all that. That is what one might call kind of disappointing. Let me actually go and close out of that. So not only does this not yield a performance improvement over using regular GameMaker instances, but it's not even close. Even if you strip out the polymorphic behavior of having a step event or a step method or a draw event or a draw method or something like that, like this, it's not even close. I would argue that even if this did yield a performance benefit, you probably shouldn't do it anyway, because directly embedding your code like this inside like obj underscore spawner step event is kind of let's say messy. You lose a lot of organizational capabilities by doing this. You lose the ability to like do polymorphic things. There are modifications that you can make to this, and I would invite you to run these tests with those modifications and see what actually happens, but I can pretty much guarantee you that it's not going to come anywhere close to just letting GameMaker do the things that GameMaker is good at. The built-in event loop for step events and draw events and whatnot is actually really efficient, perhaps contrary to what one might expect from having so much other stuff happening in the background around it. At least compared to just running stuff in regular GML, the built-in GameMaker instance loops, so the step events, the draw events, other events, are actually really efficient, even with all the other stuff they do in the background, much more so than people might think they are, and trying to outplay them yourself using regular GML is basically never going to work out. And I don't want to dismiss the 1 millisecond-ish of frame time that updating the positions of 30,000 instances took that you saw in the profiler. Like, that's not nothing, but whenever you try to optimize your game, you need to make sure that whatever optimization you're actually implementing is faster than whatever it was in the first place, which in this case is very much not how it is. And also note that, like, these are really simple examples. These objects don't actually really do very much besides move and draw themselves. If the objects that you were dealing with also had to deal with other events, such as things like, I don't know, an alarm, or multiple different step events, or multiple different parts of the draw event, or things like collision, attaching collision to them, trying to emulate those yourself in GML would just be even worse than what we're seeing here. In particular, GameMaker's collision system is unbelievably fast for what it is. In fact, even if GML ran as fast as a language like C or C++, which it definitely doesn't, you would be hard-pressed to write a collision system that is faster than GameMaker's built-in collision system without cutting out features. And trying to make something faster on your own is basically an exercise in futility. So there's one thing which, well, two things. There's two things which I haven't gone into yet here, and that is going to be the different modes of operation. So I've done this test in VM because the debugger and the profiler only work in VM. But if I were to do this test in YYC, we can go and build the game using the Yo-Yo compiler, and that is going to make things faster overall, and we can see how this is going to look. So we can't look at the profiler again because that only works in VM, but if I were to look at the show debug overlay, we could see how this is going to behave. And let's maybe zoom out a little bit. We're seeing about 60, maybe 70 FPS on a good day, with all these things flying around and doing the things that they were doing before, which is a decent improvement over how it was originally, maybe double the frame rate or so, broadly speaking, from what we were seeing earlier. So that's using our, I guess we can call them pseudo objects. If I were to comment that out, and if I were to comment back in the instance create, so that instead of doing this, we were also going to use regular GameMaker instances, I guess I might as well also comment out the step in the draw events. It's not really going to do anything because this array is now empty, but if it makes us feel better, we can comment those out. We can run the game in YYC again, and we can see that instead of getting 60 to 70 FPS doing this, we're getting more like, what's that, 100 or so FPS by doing this. This is, even in YYC, where the speed of executing GML code itself is somewhat cheaper, using pseudo objects like this instead of GameMaker instances still isn't anywhere close to just letting GameMaker do what GameMaker's good at. So that's that. I will say that I haven't done these tests in GMRT yet, and the reason for that is that GMRT is still very beta. In some places it does outperform GameMaker's VM, in other places it actually still lags behind. Yo-Yo Games has said that there are quite a few optimizations that they'd like to implement in GMRT, which they haven't gotten around to yet. And I expect that we won't really be seeing results from that for maybe a couple more GMRT updates. Hopefully now that current runtime is reaching the end of its support period, and the final LTS for current runtime is on the horizon, that will start to move a little bit faster, but we'll see. It is possible that in like 2 or 3 years, I'll come back to this and the results will be very different, but that is, at the moment, pure speculation. So the moral of the story is, well, there's a couple morals of the story. One of them is that GameMaker's internals are actually really fast, and you shouldn't count out how fast the default GameMaker systems are, and you also shouldn't, like, try to outsmart them on your own, because it's most likely not going to work. The second moral of the story is that whenever you see a claim that's saying, like, oh, you should always do this thing to make your code fast, test it. For the love of God, test it. It took like 5 minutes to write this test, and the results were pretty clear, and this is something that, unfortunately, does do the rounds pretty often in, like, the GameMaker forums and Discord and subreddit and other parts of GameMaker's social internet. And look, I don't know how else to say this. If you're serious about making games, whenever you hear something like that on social media, you should go and test it first, instead of just trying to optimize your game based on vibes.
Hey.
So hopefully this video will play some part in clearing up that particular bit of misinformation. Anyway, that's that. So if you're interested in any more of this, I will put a link to the Ultimate GameMaker optimization tier list down in the description of this video. There's a whole bunch of other stuff in here if you're interested in ways to make your game go fast, and also ways to not make your game go fast. I also do, of course, like to post a lot of other videos on how you can do things like this in GameMaker. Sometimes the optimizations that I like to talk about, like, are things that will actually work. And I like to make videos on GameMaker in general, so if you're interested in, like, 3D stuff or shader stuff or stuff of that nature, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places as well. You should all go check out Structs and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff. Link to the Steam page can be found down below. I hope you all found this educational, I guess, and I will see you all later. Special thanks to Zenjamin, Zach Robinson, Squarecrow, Spide-Eye Games, Pixelated Pope, Paradox, Nykotic, Manta Ray, GameMaker, GameArt Indie, Edward Holt, DJ Gibbles, Brenton, Bokeh Dev, and Argo the Knot for supporting these videos. If you want to join the ranks of these very cool people, head on down to the Patreon page in the video description to join the fun.